Welcome back. This is a follow-up video. Christian von Koenigsegg follow-up video for the EV Regenerative Acceleration innovation, the EV Regenerative Acceleration ReGenX generator and ReGenX quantum motor demonstrator. In this demonstration, we will be showing the load current time delay for the ReGenX generator coil. On the oscilloscope, we will also be showing the load current sine wave for the conventional generator coil that's in the prototype that will be lighting the light bulb, and then we will show the voltage and the current that's going from the conventional generator coil to the light bulb. And what we will be also demonstrating is that when the ReGenX motor coils are engaged, the ReGenX generator will generate electricity at infinite efficiency, meaning zero additional prime mover energy consumption above what is required to establish no load rotational equilibrium. And in fact, the prime mover's consumption will go down as per the previous video. So what that means is when the EV Regenerative Acceleration innovation is implemented into an EV, the EV's original drive motor is consuming less power while recharging the batteries than it is when it's not recharging the batteries. So this prototype demonstrates traditional EV regenerative braking, and it demonstrates EV regenerative acceleration. It's important to note that the EV regenerative acceleration innovation performs positive work with created electromagnetic field energy. I should say positive work with time-delayed created electromagnetic field energy, and that work is being performed at infinite efficiency. And the traditional Faraday generator coil, or EV regenerative braking coil, performs negative work at infinite efficiency with created electromagnetic field energy. So the only difference between the ReGenX coil and the Faraday coil is that the ReGenX coil operates with a load current time delay, which you can clearly observe on the oscilloscope, and it performs positive work accelerating the system while recharging the batteries. So I'm going to move this up a little so that we can, hopefully we'll be able to see the tachometer readings. Okay, let's fire it up. So here we have our EV that is cruising down the highway at about 3,400 RPM. Now I'm going to put it into regenerative braking mode, and we will be powering the light bulb and performing negative work at infinite efficiency with created electromagnetic field energy, and then we'll be performing positive work with time delayed created electromagnetic field energy and accelerating the system while supplying additional power to the light bulb. So currently the prime mover's energy consumption is 149 watts. That number is going to increase to about 169 watts in regenerative braking mode, and then it's going to decrease to about 146 watts in regenerative acceleration mode. Okay, so here we go. So 3482 is our idle speed. So now we'll go into regenerative braking mode. Pay attention to these numbers here and that number there. So we're delivering 10.2 volts to our light bulb. .89 watts to the light bulb, and we are in regenerative braking mode. That should be better. Okay, I'll put it back into no load. So we're in no load right now. The prime mover is consuming 147 watts. And now I'll put it into regenerative braking mode. Our idle speed is 3,482 RPM. So now we're in regenerative braking mode. The input to the prime mover has gone up to 168 watts. Speed has gone down to 3,451 RPM, and we're delivering about 8.9 watts to the light bulb. Now I'm going to put it into regenerative acceleration mode. Pay attention to this number here. We started at 148, and the output to the light bulb is also going to increase while the prime mover consumption goes down and the speed goes up. So the power delivered to the light bulb is currently at 10.23 watts across the light bulb. Our prime mover input has decreased to 144 watts, which means the prime mover is consuming less power when generating electricity to the EV's battery. And we can see the load current sine wave on the oscilloscope, which demonstrates that the ReGenX generator coil's load current sine wave is delayed by about 50 degrees versus the load current sine wave for the conventional generator coil. So now I'm gonna basically increase the load current delay to 90 degrees. The speed will go up a little more, the output will go up a little more, and the input to the prime mover will basically go down. So the input to the prime mover has gone down by basically about an additional 4 watts. So basically we are generating power in regenerative acceleration mode with less power than is required to idle the generator on no load. And we can see that the load current sine wave for the ReGenX generator coil is 90 degrees out of phase with the conventional generator coil, meaning that the regenerative braking component has been completely reversed. So I'll put it on to no load again, and I'll show you the whole thing one more time. So we're back to no load. We'll put it into regenerative braking mode. And you can hear this system decelerating. The input to the prime mover has gone up by to 167 watts, and we started at We started at 148, 147 watts to the prime mover. Conventional EV regenerative braking. And EV regenerative acceleration, where the more power that's sent to the EV's batteries, the faster the system's kinetic energy increases, and the less power is required by the EV's original traction motor or the internal combustion engine vehicle's hybrid motor or internal combustion engine motor. So again, this is the ReGenX generator coil, or the ReGenX, the EV Regenerative Acceleration ReGenX coil, of which we will be manufacturing about 65 billion coils starting in 2027 at our new manufacturing facility, and basically with a market valuation of between 10 and 13 trillion dollars over the next 10 years. Thank you for taking the time to watch this video. Cheers for now.